For thousands of years, people have been fascinated with the points of light that dot the night sky. While early humans thought these lights were mythological or divine entities, we now know that almost every one of these lights is a star. Much of what we know about the universe can be traced back to a single invention, the telescope. These are some of the first telescopes ever built. They are over 300 years old. They were built by the Italian astronomer, mathematician, and physicist Galileo Galilei. Galileo's telescopes were ingeniously simple. They were made of little more than two convex lenses held in line by a tube. Convex lenses are thicker in the middle than they are at the edges. But these simple devices allowed Galileo to make some amazing discoveries. Galileo was perhaps the first person to use the telescope in a systematic and scientific way to observe the night sky. But he didn't invent the telescope. That honor goes to a Dutch eyeglass maker named Hans Lippershey. Lippershey's original telescope from 1608 was used for military purposes. It gave ship captains a close-up view of their enemies during sea battles. When Galileo heard about Lippershey's work, he built his own version and turned it toward the heavens. In one of his many discoveries, Galileo determined that the moon was not smooth, like everyone at the time thought. It had mountains and craters. In addition to studying the moon, Galileo was also the first to see the four largest moons that orbited Jupiter. But Galileo's discoveries were not merely new sightings. His observations supported the theory of Copernicus that the planets orbited around the sun, not Earth, as was commonly believed at the time. This was a radical idea and called into question centuries of scientific thought and contradicted some religious teachings. During Galileo's final years, he was made an outcast. He died in 1642. But the work of Italy's greatest astronomer was finally recognized and honored. Italy's first national telescope was called the Galileo, and NASA named a space probe designed to study the planet Jupiter in his honor. Galileo turned an instrument of war into an instrument of science, and telescopes have been used ever since to collect the universe's light and turn it into enlightenment. What discoveries about the moon and Jupiter did Galileo make with the help of the telescope? As you watch this video, think about how telescopes collect light to form an image of a distant object. Because of the vast distances between us and other objects in the universe, the light from most stars takes many years to reach Earth. Even light from the closest star to Earth, aside from our sun, called Proxima Centauri, takes 4.2 years to reach Earth. And the light from most of the other stars has taken thousands and sometimes millions or even billions of years to reach us. Distant objects are hard to see because light from an object spreads out. So the farther you are from the object, the less light you receive from it. But conventional telescopes magnify this light. Light-collecting telescopes use glass lenses or mirrors to gather the rays of incoming light. When you look through the eyepiece of a conventional telescope, you see a very small part of the sky, but that part is enlarged so you see it more clearly. Some telescopes have huge lenses and complex motors to slowly spin the telescope so it can remain focused on objects as Earth spins. The first telescopes were refracting telescopes. Refracting telescopes are shaped like long tubes. They usually have two lenses, a larger one at the front and a smaller one at the end where you look. The larger lens, called the objective, bends the light, forming an image. The bending of light as it moves from air to glass is called refraction. As parallel rays of light pass through the lens, they are focused at a single point, the focal point. The length from the lens to the focal point is the focal length. As light continues on and enters the second lens, the eyepiece, it is refracted again and then continues on to the viewer's eye. Refracting telescopes are limited because their lenses are made of glass. The world's biggest refracting telescope is only just over a meter in diameter. If a lens were much larger than this, the weight of the glass in the lens would actually make the lens sag and distort the image. A second type of telescope, the reflecting telescope, was designed by Sir Isaac Newton in 1668. As its name implies, a reflecting telescope has one or more mirrors that reflect light. This style of telescope can be much larger than a refracting telescope because it uses mirrors rather than an objective lens. Since light does not have to pass through the mirror can be supported in the back so it can be much larger than a lens. In a reflecting telescope, light enters the telescope tube and is first reflected by the concave or bowl-shaped mirror, called the main mirror in this diagram. The main mirror is shaped so that the light converges into a single focal point inside the telescope. Then the secondary mirror reflects the light onto the eyepiece, where a lens refracts the light into the observer's eye. The most modern reflecting telescopes are astounding. They rely on a series of mirrors working together to form a single reflecting surface. Their light-collecting surfaces can be 10 meters or more in diameter. The light that makes its way to Earth passes through the atmosphere before reaching an observatory. As it travels through the atmosphere, the light is distorted. Water vapor, dust, heat, and other things in the atmosphere can all distort light. On a clear night, these factors are minimal. This is a photograph of Saturn taken through a telescope on a clear night. But this is what Saturn looks like when water vapor and other atmospheric phenomena distort its picture. In addition, the presence of light from street lamps, house lights, and other kinds of electric lights can reduce the clarity of a star's image. We call this light pollution. These disturbances in the atmosphere can make incoming light from distant objects refract and scatter, and cause the light to shimmer and distort. At higher altitudes, these distortions aren't as great, so telescopes are often built on mountaintops. This helps, but doesn't entirely eliminate distortion. To do that requires locating a telescope outside Earth's atmosphere, in space. The Hubble Space Telescope was launched with this idea in mind. Orbiting 600 kilometers above Earth, this reflecting telescope with a 2.4-meter concave main mirror gave astronomers images free of atmospheric distortion and light pollution, and provided detail that was not possible from Earth-bound telescopes. What's more, a series of other instruments on the Hubble Space Telescope were designed to detect light and send signals to Earth, detailing the quality of the light. The eyepiece is actually on Earth, where the electronic signal is used to create images of astounding quality. We've come a long way since the early telescope that Galileo originally used to examine the moon and nearby planets. But despite how much they have changed, telescopes remain our most effective way to explore the far reaches of the universe.